Hello and welcome to episode 10 of RPG Tutorials. Somehow it's already episode 10, so I'll make sure that I make the solution available as I do on every 10th episode. If you are enjoying what I'm doing here, make sure you hit that like button, subscribe, comment. Those are huge. I see that if I get any comments on these tutorials, they jump off the charts on what they do, at least in terms of how my channel does. So that would be very helpful. Today we are going to cover doing some keyboard movements, and we are going to cover turns. We are going to add functions to handle the movement. We're going to error check that movement. We are going to do sudo turns with a timer because we don't have enemies yet. Typically it'll go we move, allies move, enemies move, we move, allies move, enemies move. That's the basic rogue-like, and we're going to add plenty of rogue-lite elements as well, so I'm trying to make sure I say those correctly because they do have real meanings. I know a lot of people conflate the two. They're not the same thing, and we'll go into that later, but we're going to add it the level packet to handle the turns, and then we're going to test it. In fact, I think we're actually going to add the packet first, but regardless, that's what we're up to. It should be a relatively short one today, and it should get us set up to start looking at adding some obstacles and stuff like that. So, all right. So first things first, let us get turns working first. I know I said the other stuff first, but we're going to do it this way. Okay. Level. We want to add turns to our level. And the way we're going to do that is we're just going to use an int to say whose turn it is. And so, for instance, right now, turn 0 will be our user, so us. And turn 1 will be, right now, everything else. The point of this is to pass it into our level packet. And then you might ask, why am I not using the state for the turn? You could. But I think I'm going to use the state for things like menus be open and stuff like that, in order to have a different set of variables to do different things. Okay, so for level packet, we just need to take in turn. And then same thing here. Int turn. And then turn equals turn. And I hate that they don't put that space in there. Okay. So super simple. We're just passing turn in. You can see we already did that here. That now makes it into our hero, which we go into our hero. So we are going to remove this for a second. We're going to comment it is what we're going to do because we're going to use this at another time, parts of it. But we're going to use that when we go to handling moving more than one space and stuff like that. So this was test code, but we will use it later. So we're just going to keep it there like that. You can say that's sloppy, but we are going to reuse it. So at least that's the way I envision what I'm doing. So first we need to figure out, first we need to figure out what turn it is. So turn is in packet. If packet.turn equals 0. So that's the only time we're allowed to make these edits for moving our character around is during our turn. And that is when turn is equal to 0. Vector 2. Loc change equals, and then we're going to need a function here. So the function is going to be called process movement. So let's come down here and put it together. Public virtual void, whoops. Public virtual vector 2 process movement And in reality, you might want to call this process keyboard movement, but we'll get there. We'll get there. So here we're going to have the vector 2 is being returned, and if nothing is done, we're going to set that up real quick. So just say return new vector 2. So if we get to the end, we're just going to return don't do anything, right? That would be 0, 0 movement, which would be don't do anything. So we're going to process our arrow keys here. You can process other things if you want, like ASDW, stuff like that. But we're going to process arrow keys for right now. And you can add to that, or you can do something completely different, or whatever it is you feel like doing. So the right arrow is just called right with the code that I've given you for keyboards. The code for left is just left. The code for up is up, and the code for down is down. So I know, super simple, but we got to do it. Okay, so what do we want to do when we press right? Well, we're going to return new vector 2, and then moving to the right in the array is 1, 0. So we're moving x 1 and y 0. Moving left is -1, 0. Moving up, now this is where it gets a little weird. Moving up is actually -1, because our array for our so pretend this is our grid right here. So visualize this square. Top left is 0, 0. Bottom left is count, count. Right? Well, count -1, count -1. You get what I'm saying? And so if we move up, we're actually going -1. So there you go. And then down is +1. So that's backwards of what you might think, but that is what it is. So just, don't mess that up. Okay, so here we're going to say process movement. All right, so what happens here? If nothing happens, right, we come down here, we're not pressing anything, we hit 0, 0, it does nothing. We'll check for that in a minute. If we're pressing right, then we get right. Also knows these are single presses, so holding the button won't do anything. So just keep that in mind. All right, so that's what's happening. It does something if we're pressing a key for the first time, and does nothing otherwise. So it just loops through, doesn't hurt anything. We can keep moving. The next thing we need to do is we need to find out, well, what location are we currently in? So we go vector 2, and we say temp loc equals, and then we need to know the current location of our hero, which we don't have yet. So we'll wait on that, and we'll say loc change. So we're going to break this on purpose and leave it in an error state so that we don't lose it. Okay, and then we're going to go to our unit, because all of our units, not just heroes, should know where they belong. And to do that, we're going to say public vector2 current loc. Okay, and then current loc is interesting in some ways because it needs to be set every time we move the character. Well, what does that mean? Well, we need to create a function, or you can do a property if you want. I like to do functions. Virtual void set loc. Okay, and set loc is going to take in the level packet, and you'll see why in a second. Level unit packet, and then so that one's just packet, and then vector2 the loc that we're trying to assign. So in here we're going to say current loc equals loc, and actually just to fix some, if you're careful you don't have to do this, but if you are new you really should be doing it this way so you don't make mistakes, and basically declare a new vector, because otherwise if you pass in a vector that is being used by something else and they change it, then it changes here, and we don't really want that. We want this to be its own thing. Yeah, virtual. I used the wrong V. Virtual, not void. Okay, and then the other thing we're going to do is after we set the location, we're going to say the position of the character is equal to packet dot grid. This is going to look real familiar from last time. Get pose from loc. We are going to say current loc, and then we want the center of it, so true. So this is why we created a function for it. And I don't know why it's erroring, so let's take a look. This should be void. It must have auto-sensed or something. I'm not paying attention all that well sometimes. Okay, so we have that. So we set loc that way, and then we need to set the loc every time that we put it anywhere. So our character here in level, when we're setting it right here, so we're setting the location instead of this, right? It should be hero dot set loc, and that should be this location here. And we can pass in. We don't have one of these set, so we'd have to create one real fast. Grid's created up there, so that's fine. Okay, so we can do this, and we can put it in here, and happy days. So now we have our grid, so we can pass that in. Unit packet, done. Okay, so that passes in, so now that uses our set loc, so now it knows what position we're in, so that's good. The other thing we want to do also is to say we want to instantiate this, so we want to say current loc equals vector2.0. Done. Okay, so we've done those things. So we now have a location for our character. So we know the current location of our character is current loc. Okay. So now we have added our movement. We've taken that and created a new vector out of it. So by doing this, we are creating a new vector. We don't need to do the new vector2 thing. You can, if you so choose to, because it makes you feel better about it, but you don't have to. All right. So now we want to figure out where this new location is. So we've changed the location. We now need to error test our location, right? So we're going to need a function to error test this. But on top of error testing it, we are also going to need to say we only want to do this, which is to set the new location if locChange x is not equal to 0, or locChange.y is not equal to 0. In other words, there is some kind of change, right? We shouldn't be in here unless there's some kind of change. Now we're going to put a function in here that is going to deal with testing our location. So to do that, it's very simple. Public virtual bool test new loc. We are going to need the grid here, so we're going to have to get our level unit packet, and vector2 temp loc. Okay, so that's the location, the new space that we're currently trying to see if it's allowed to even be there, because like if we go outside the grid, we want to error, right? We're also going to test against locations that can't be in eventually, but that's not now. Now we're just testing against, hey, does that exist? Okay, so we are returning a bool, and to do that, we just kind of go through and we test for the different things. So when does the movement error? Well, it errors if temploc dot x is less than 0, which means we are in negative territory. You can't have a negative slot in an array or a list, so that is bad. Okay, so we're going to return true because it errored. TRUE. Good. Okay, next thing, if temploc dot x is greater than, I'm sorry, first one was less than, this one's greater than packet dot grid dot slots dot count -1. Okay. That will also return true. And then you can ask, well, can't you just say or and put that in? Of course you could. I'm not exactly sure how this function is going to play out in the future, and so I'm leaving it divided up because I think that there's a good chance that we are going to treat them slightly differently. So for this purpose, I'm going to divide all these into their own if statement. All right, temploc dot y less than 0, same thing. That will overflow it, return true. And then same thing here. We're going to not type it because I don't want to type that much again. Y, and then instead of this, we're going to say slots 0. So we're assuming there's at least one row. And then we're going to figure out how many columns it are. And because we know that all of the rows have the same number of columns, which doesn't have to be the case in lists, but it is the case in what we've done, and will always be the case in my grids. We can say, okay, we only have to look at the 0th place. And then because we know there's at least one, this is all legit and fine. Okay, and then our final thing will be return false. So this will get us to the point where we can test to see if we have a legit space. So we're going to say not. So this only happens if it doesn't error. So if it doesn't error, then we have packet and we have temploc. In here, we are going to say set loc, and then we're going to pass in packet and temploc. Then after that, we're going to say packet turn equals 1. Okay, so because packet is passed in by reference, which means that when I change it here, it changes it everywhere. Changing the variable inside hero will change it for level. Be careful doing that if that's not what you intended to do. In this case, that is what we're trying to do. Another way to do this would be to pass back the change in the turn. But since we're already passing our turn in, we might as well use that to come back out. Okay, so that is the code for hero. That should be all for unit. Now what we need to do is we need to be able to turn the turn back. So what's going to happen now is we can move once, but we can never move again. So in order to fix that, we have to say something like if turn equals 1, and what you'll notice actually is turn in here is equal to 1, but turn here is not. So we have to update that. So if first of all, let's fix some things. We didn't test for hero null here. So hero not equal null. And then in here we're gonna say it's all updated, right? Oh, this is set hero. I'm in the wrong spot. That's why it's not there. I confused this one with this one and then went in the wrong function. Apologies. Okay. We're going to say turn equals, so this is directly after the update for turn, equals whatever the packet, so level unit packet dot turn is. Very simple. Nothing special. Okay. And then we have the if turn stuff, which is in the wrong spot now. So let me move back up. Mistakes were made, but they are now rectified. All right. We need a timer. So we know how to do timers. Timers go at the bottom other than pass objects. So public MC timer. And this one is just going to be called temp turn timer. Why temp turn timer? Well, because I don't plan on using a turn timer, most likely with this project. I don't see the point in timing you. But right now we're trying to make sure that we have a pause that we can see and we know that our turns are working. So we want temp turn timer dot update timer. And then we want to say if temp turn timer dot test, meaning that it's over. We say turn equals 0, so we go back to the hero's turn, and then we temp turn timer dot reset to 0. Okay, that is our loop there. So basically we come in, and every time we loop through, we're looking for hero input. When the hero input comes in, turn timer changes. We come down here, we loop for a second, and then we can keep moving. Let's see if it worked, or if we gotta fix some things. Okay. Here we go. Just gonna click through. So you can hear me mashing the button, and it only moves about every 1 second, right? So, ooh, I'm pushing down, and it's moving. It's moving right, which means that I didn't change my 0 positions. So let's go here, and I didn't. You can see here we're moving on the x-axis, not the y-axis. Mistakes were made, and now they're rectified. So it's always fine to make mistakes, right? Just get them fixed. Test your code. Make sure you know what's going on. Come out here. Say play. Just skip through. You can hear me mashing. We're going to go down. Now we're going to go left. Down, right, up. All right. That is what we're trying to do today. We're trying to simulate turns, and we're trying to be able to move one at a time. This would be your standard movement for a rogue-like game. We are going to allow for multiple moves per turn in this specific game. So we'll go into some more of that later. We're actually going to do probably grid obstacles next. So walls and stuff like that. I believe. That's, I think, what I'm most interested in doing, so I think that's what we're going to do. If you guys have made it this far, please take a second, hit that like button, subscribe, comment. If there's anything you want to see me do, please let me know. I'll do my best to get to it if it's something that fits this game at all. If it doesn't, then I may have to tell you I'm sorry, I can't really do that with this project. And maybe I'll try to do something similar that does fit. I'll try to figure something out. But you know, it really does help to have the interactivity between the likes and the comments. Please take a second and do those. It doesn't hurt you at all, and it really helps this channel, and it helps me stay energized towards these things. Okay, guys, I will see you guys next time. Have a good weekend.